I would like to help such people. I studied PDEs, Fourier series, and transform prior to my undergraduate studies. My main challenge is implementation in code. That is one of the reasons I am learning to code. I want to be able to express mathematical ideas and models in code. I want to be able to think mathematically and algorithmically as well. I have a little experience in Python. I can use MATLAB if the need arises. But sometimes it is impossible to implement certain nuclear models in code. I had problems at the beginning of my master studies with this. I could derive the equations, but I find it difficult to implement it in code. So I started learning coding. I started with Python, but I became comfortable with C++. It is challenging, but I believe it will be worth it in the long run. Since watching your videos and reading some books, my understanding of the language is improved a lot. I'm willing to help such people. Today is December 19th, 2022. This is my 165th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL DBB Vulkan. I will discuss implicitly defined functions, derivative of higher order 1. I will discuss extended Newton method. Extended Newton method. I coined this term. I said I coined this term. We will solve Thomas's Calculus 13th edition, chapter 3.7, Implicit Differentiation, in page 173, example 4. In this book, 173, if you scroll down, derivatives of higher order, we will solve this problem through 2 or 3 sessions. To solve this derivative, we need to find out values of x and values of y first. This problem is by no means simple. It is very challenging. Open up Visual Studio Code, CPP 17 2023 parallel. Select empty space. Click this button, 165. Newton. Click this button, newton.cpp, hit enter. Ctrl V. I will close this empty file. I will arrange side by side like this. Include CPG, CPG, SCD, extensions. Include CPG, CPG, calculus. If you have a squiggle, you have to make some settings. Ctrl-Shift-P, edit configurations, JSON. If you do not define this macro, for example, like this. If you do not define the macro, you will have squiggle. For the test, I will copy the function name. For the test, implicit derivative, page 173. This is page 173, example 4. Example 4, solve for x. I defined a function. Copy this function name, paste it here. You will have squiggle. Then Ctrl-Shift-P, edit configuration JSON, quote, $MSVC underscore inc /2 comma. You have to set this environment variable. Also, C++ standard should be C++20. Then the squiggle goes away. You do not have this environment variable. Please double check this message. Program files. Open up. System. Program files. Here, Microsoft Visual Studio. Microsoft Visual Studio 2022. Community. Then VC Tools. VC Tools. Then MSVC. MSVC. Then 14 certified blah blah something. 14 certified blah blah something. Depending on your installation of Visual Studio, this version can be different. Double click it. Then you can find include. We need to set this environment variable. Copy. Here, search. Environ. Edit the system environment. Environment variable. You have to define MSVC Inc. Edit. Here, you can copy and paste the folder. Please understand, this subfolder can be different depending on your Visual C++ installation. So, you have to find your own folder path. Then define MSVC Inc. Click OK. Click OK. Now, you have to close it. Click OK. Then restart. Then your squiggle will go away. Okay? Your squiggle will go away. Now, here, auto app. We define this function. We need auto x, auto y. So I copy and paste it here. Return 2 times. We need parentheses, power underscore 3 parentheses. 3 times parentheses, power underscore 2 parentheses minus 8 semicolon. So this is this function. I would represent like this. Don't miss semicolon. Now we have to understand what picture this function. I will use Mathematica. I will use Mathematica for educational purpose, but you have to be able to draw, to picture, or graph this function by yourself without using such tool. Anyway, contour plot. This is square bracket. Okay, this is square bracket. We can specify 2x cube minus 3y square. I use 2 equal symbol 8. Then curly brace. This is curly brace. This is x range. X range 0, 0 up to, for example, 10. Now copy this. This is x variables range paste. This is y variables range. It can be minus 10 like this. Now shift enter. Then it draws such graph. Please understand, in this graph, when x is 0, this graph doesn't make any sense. So, in this graph, this is x-axis, this is y-axis, okay? In x-axis, x cannot be 0. I want to know the coordinates of this point. How can you solve the coordinates of this point? So, we are solving this implicit function for x like this. Although x, this is dummy value. We don't know the value of x yet. So x equals 0.0 is simply a dummy value for x. This value is ignored. Now, although y equals 0, this value for y is fixed, known value of y. In this graph, here, this is the value of y. The value of y is 0. When y is 0, we have one value of x. When y is 0, we have one value of x. We want to find out this x. Now, although x range, we can specify using CPT make array. This is function. We define the range of x. For example, from 0.0, we can specify arbitrary value of x. This is x range. Now int split x range. We can split this range into 10 segments. Okay? Then although solution x CNA extended Newton method, we are solving implicit equation for x. The index of x is 0. The index for y is 1. We are solving for x, so it should be 0. This is very cryptic. Here, I will explain how to extend your own library. For example, holiness.hpp, if not df, holiness.hpp, define holiness.hpp, and if put end over file holiness.hpp. Now create a namespace. Namespace holiness. End of namespace holiness. Then you can specify like this. Context per inline int wrt x 0. Copy, paste. WRT stands for with respect to y, with respect to z. This is 1, this is 2. You created your own namespace. Then in this file, you can include the file name is holiness.hpp. Then here you can declare using namespace holiness. Then we can use with respect to x. Okay, you can extend your own library like this. Then we provide split x range. Then we provide x range. Then we pass function f. Then x, y. My machine is very slow, so IntelliSense does not function properly yet. Now, std cout solution x with y, we pass y, then solution x, cpg and l. So we created this function with respect to x, means we are solving this function to evaluate solution of x. We assume the value of y is fixed or given or known. We want to find the value of x, so solution x with respect to x. With this, open up your command prompt. You can open any command prompt. cd 165 Newton clang plus plus std c++20 Newton.cpp ltbb 12 or c.exe. Sorry, I made a mistake here. It should be cpg. I fixed. Now we rebuild. I'm very sorry. Here, namespace, CNA, CPG, numerical analysis, namespace, CPT, CPG, types. Then it should be CPT. Now with this, we build again. I'm sorry, once again. Using namespace, CPG, operator, and constants. CLSC. Now we found solution x. When y is 0, x is this value. In this graph, when y is 0, we have a single value x. Okay, this is the value of x. Now we will solve for y. Copy, paste. Implicit derivative, solve for y. Okay, then here it should be y range. Okay, the rule is change it. This value for x is known and fixed. This value for y is dummy. Now this is range of y. Okay, in this graph, when a value of x is given, y can have two values. So we specify range of y. X cannot be 0. I will set arbitrary value, for example 4. Then split y range. X range can be arbitrary value, for example negative 20, positive 20. Then this is solution y with respect to y, range y, split y range, then y range. Then here solution y x equals x. Then this is solution y. I will copy this function, paste it here. Now we rebuild CLSC. So in this graph, when x is 4, somewhere here, we have two values of y. This is negative 6.32, somewhere here, 1 y. Also positive 6.32, somewhere here. When x is 4, there is two value of y. We have to know how to evaluate this function, how to find the values of x, the values of y. Okay? Then we can test this part in my next episode. I will give you one assignment. Here in figure 328, we are given this function. When a value of x is given, you have to find out three values of y. This is your assignment. When a value of x is given, you have to be able to find out the values of y. Or when a value of y is given, you have to be able to find out the value x. The value x. The value x. You have to be able to find the values of x and the values of y using this graph. This is your assignment.